Hi there, my name is Miss Townsend and I love movies. Welcome to Math with Townsend. I said movies. I love movies and I love math. This is video number 6 of taking up the practice questions that you were given in class. These questions are primarily taken from the June 2011 EQAO. So where were we? Aha, question 34. Now this one I know was not taken from June 2011. It was taken from some earlier EQAO, but I don't think we've done enough practice on ratio, so I threw it in. It says Darwin is making a drink that is a mix of crystals and water in the ratio of 2 to 5. So whatever order they say it in has to be the same order they give it to you. So crystals to water is therefore 2 to 5. Darwin starts by mixing 4 cups of crystals and 9 cups of water. How many more cups of water should he add to have a 2 to 5 ratio? So if he added 4 cups of crystals, he should have added 10 cups of water because the multiply factor would be times 2. So 4 cups of crystal requires 10 cups of water, but Darwin's only got 9 cups of water, so he needs 1 more cup to get the right ratio. A lot of EQAO questions are actually just as simple as I just did, but they're complicated if you don't carefully read. So there's nothing I can do other than reiterate that reading is very important. Take the time, look at all the words. Next question. A rocket is fired upward from the ground. The equation below shows the relationship between the height of the rocket above the ground, and t, time in seconds. So here's the equation, and it's a relationship between height and time, and I can tell it's not a linear relationship because I've got an exponent on my variable t. So it's not linear. Which of the following is the height after 4 seconds? So the equation is an equation for height, and it says if you know time, I can tell you height. That's what the equation says. So we know we're looking for a 4-second time period. So let's use 4 seconds for time and see what we get for height. So now that I've done my substitution, I just have to follow the rules of Bedmes. So I'll do the exponent first. 4 squared is 16. Now I have some multiplication to do. 60 times 4 is 240. 5 times 16 is 80. And then finally, the last step will be subtract. 240 minus 80 is 160. And that's one of our answers. So 4 seconds after being shot, the rocket is 160 meters above the ground. The ratio of girls to boys in Mr. Dilworth's music class is 18 to 12. What percent of the students are boys? So girls to boys is 18 to 12. Now, if I want to talk percent, I need to know the total. So if there were 18 girls and 12 boys, there would be 30 total students. So that's also sticking to the same ratio. Now, therefore, out of 30 students, 12 of them are boys. So as a percentage, 12 divided by 30 times 100 gives you 40%. Now, hopefully, you didn't necessarily even need to do math. You can look here and say, well, it's got to be, if this is boys, I know that there are more girls than boys. So therefore, this is too many boys. It's more than half. Too many boys. And then 12% is an awful lot less. And this isn't an awful lot less, it's just less. So you could have even done this one logically. So I believe, yes, that's the end of the multiple choice. So let me just press pause in the video, you won't even notice, and we'll start taking up the longer answer questions. Hi, bet you didn't even know I was gone. So now into the full answer questions. So remember on the EQAO, these are questions where you're trying to be as clear and use good communication. You're trying to organize an answer, and you're trying to do as much math as makes sense, even if you're not sure how to get the right answer. So let's look at the question. It says, follow the bouncing ball. The scatter plot shows the relationship between the rebound height of a ball and the height from which a ball is dropped. So for example, if I drop a ball from 1 meter, it rebounds to almost half a meter. That's what this dot means. This dot means that a height of 2.5 meters resulted in a rebound of 1.25 meters, and so on. So before we go any further, let's make sure you understand reading the scale on a graph. On the horizontal scale, I go 2 units to find 1 meter. Therefore, each box must be a half. So a half, 1, 1.5, 2, 2.5, 3. That's pretty straightforward. On the vertical axis, it takes me 4 boxes to get to 1. Therefore, each box must be a quarter of a unit, or 0.25. Okay, so make sure that you know how to read a scale properly. That's how I knew that this point here was at 2.5 and 1.25, because I looked at where it was in terms of the boxes. So now that we have reviewed that, let's look at the actual question. Draw a line of best fit for the data on the grid above. Determine an equation for your line of best fit. So I don't have a ruler, but I do have fancy technology. And your goal when drawing a line of best fit is not to pass through as many points as you can. It's to make sure that your line has about half the points above and half the points below. So your line should be in the middle of the points. Now these points are fairly close together, so it's even hard to see the points when I've got my line here. Let's see if I can adjust my line to see the points a little nicer. And I'll just make it a nice skinny line. There we go. So when I made the line even skinnier, now we can see that I've got a couple points below, a couple points on, and a couple points above. So that's a pretty decent line of best fit. To find the equation of the line of best fit, well, to find the equation of any line, you need 2 points. So I'm going to take 2 points, and I'm going to be doing some approximation, but I'll see how good I can get. So this point here is on the line, and this point's on the line. So where are these points? Well, this one down here, I know it's at half a meter. And then what would this be? Well, I know this is 0.25, so I'm going to say it's 0.3 because it's a little bit above 0.25. What about this point? Well, I know it's at 3, and over here, it's a little bit above 1.5, so I'm going to call it 1.6. Obviously, I'm approximating, but you do your best. So the slope would be 1.6 minus 0.3 over 3 minus 0.5. So I get 1.3 over 2.5. And let's make that just a simple decimal value because we don't like having decimals inside of fractions. So that would be 0.52. And let's just say that's 0.5 and look back at the graph. There's another way of finding slope, obviously, and it's to do rise over run. And if you look at the graph, I appear to be going about up 1 and over 1. And don't forget to look at the scale. That would mean I'm going up, oops, up 0.25 and over 0.5. And in your calculator, that gives you this slope that I'd already found. So the equation of the line, now the other thing I'm going to need is the starting point. Pretty clearly, this is a starting point at 0, 0. And that makes sense anyway. If I drop a ball from 0 meters, I expect it to bounce 0 meters. So the equation would be y equals 0.5x, except for those are not the right variables. Make sure you use the variables you're given. Rebound height equals half of drop height. Determine an equation for line of best fit. Show your work. Here's my math. And I'm going to write down here that it's direct variation. And that's to make sure that whoever looks at this knows that I know why I don't have to do plus b. Because it's direct variation, it passes through the origin. Okay, let's look at the next long answer. Hannah's total pay includes a base salary and a percent of her sales. The following table shows her total pay for 3 different sales levels. Determine Hannah's total pay when her sales are $47,000. So I actually treat this kind of the same way I treated this question. I'm looking for an equation, because if I can find the equation that relates pay to sales, then I can just solve for what I'm looking for. So we know that Hannah's pay is equal to a base salary plus a percent of her sales. And again, that sort of looks like a linear equation. This is the starting amount, or the flat fee. This would be the slope. So how am I going to find any of the information? So I'm going to look for this equation, P equals M. Now I hate using the letter S. I'm going to use P for pay, but man, I'm going to use D for dollar amount, and I hope that's okay. So I need to find, as always, slope and starting amount. So let's take 2 points. All I need is 2 points, and let's subtract them and find slope. So 1825 minus 1700 is 125. 17,500 minus 15,000 is 2,500. And therefore we have a slope of 125 delta y over delta x, and that gives us 0.05. So I already know that 5% is the percent she gets from her sales. So I have this equation, P equals 0.05 times the dollar amount plus the starting base fee. So I still need to find the base fee, and the way we do that is we're going to take one of the points that we know, 15,000 and 1,700. This is D, and this is P, and we're going to sub them into this equation. So 1,700 is her pay when she earns 5% of 15,000 and her base salary. So 5% of 15,000 is $750. So her pay was $750 plus her base salary. So by subtracting 750, now I know that her base salary is 950. So this is what Hannah gets paid. 5% of her sales plus $950. Now I can answer the question. What does Hannah get paid when her sales are $47,000? So now it's just a simple substitution. Substitute 47,000 for her sales and then do the math. So 5% of 47,000 is 2,350. Add to that $950 base salary, and we discover that her pay would be $3,300 for sales of $47,000. Okay, so again, the last two questions, you should interpret them very similarly. Both of them basically say, take 2 points, find me the equation. And that's obviously a really core piece of learning that you have to know from this unit. So that's the end of time for this video. So I'll meet you in the next video.